So part 2, we just established what the parent function 1 over x looks like for a rational equation. There are some pieces of information that I will ask you for when we do one of these. We talked in the last video about how rational graphs have both types of asymptotes. I'm going to have a vertical asymptote that defaults to x equals 0 and a horizontal asymptote that defaults to y equals 0. We got x equals 0 right here for my vertical, y equals 0 right here. The domain and the range for this graph. The domain is the x's, and this graph uses almost every single x, but the one x it doesn't use is 0. It won't actually hit on there. So what I'm going to do is I'm going to say all real numbers, but x can't equal 0. So it's x can't equal the number we used from our vertical asymptote. The range, the graph is going down forever, up forever, but it doesn't actually hit 0 here as well. So my range is all real numbers, y can't equal 0. One final thing I want to talk about in the parent function before I move on to the other examples. If I look here at my center at 0, 0, that point 0, 0 isn't on my graph, but it's where the dotted lines meet. And if I take that point and I go up 1, over 1, I actually do land on my graph. And if I go down 1, left 1, I also land on my graph. So I can get 2 points on the graph by using my little fake slope right here. And that makes graphing these actually pretty quick because we can still use our shortcuts. So moving faster through our other examples here, I see this graph has numbers on it, which is going to move it around. This guy is my inside, and that moves me left and right. So this is going to go left 4, and then it's going to go down 2. So the normal translation rules we've used all year long are going to work out for us on this graph. Well, if I go left 4, that is going to affect my vertical asymptotes. We talked about that with log graphs. So if my graph goes left 4, instead of being at 0, I'm going to shift and have a vertical asymptote at negative 4. So that controls my vertical asymptote. I'm actually going to draw in my dotted line before I make my picture. Then I have a down 2. Well, down 2 is going to affect my horizontal asymptotes. So I'm going to go down 2 and draw this guy right here. And then just like I looked where the dotted lines met, that was the center of my problem up here, I'm going to count from right there where they meet. I have a 1 up top, so I'm going to go up 1, over 1, dot right there. I'm going to reverse it, go down 1, left 1, dot right there. Those are the only dots that I need you to have to draw your picture. You use the asymptotes and it guides it. You draw this part of the graph, arrows on the ends. Oops, totally missed my dot right there. But you draw your other part of the graph in the same fashion. So once you have your starter dots right there, you just draw the picture by where the dotted lines guide you. They're actually kind of easy after you learn how. Vertical asymptote is x equals negative 4. Horizontal, y equals negative 2. Domain is all real numbers, except it can't equal the number on the asymptote, which is a negative 4. Incidentally, that totally makes sense because if I put in a negative 4, I would divide by 0. So this is consistent with what we've learned about with restrictions. And the range is going to be all real numbers, except that y can't equal a negative 2. So if you can do translation rules, which you all totally can, you're going to be great on these examples. I have 2 more to go through quickly here. This guy is going to go right 5. So that's going to be where I put my vertical asymptote. It's going to go up 3, and that is going to affect my horizontal. So those are my asymptotes in the problem. I look at where they meet, and I use this guy up here as my fake slope. I will count up to right 1. So up to right 1 is there. I'll reverse that and go down to left 1. And those are going to be my 2 dots that I use for my picture. So I still draw them the same way. I got this going on. Vertical, x equals 5. Horizontal, y equals 3. All real numbers except 5. All real numbers except 3. Pretty quick once you learn what you're doing. Final example here. And on this one, we have 2 things going on that are different. There's a negative right here, which we'll talk about. This graph is going to move left 2. So that'll influence my vertical asymptote. There's no up and down movement, so I'm going to stay at 0 for my horizontal. And this time my graph has a -1. So from where my asymptotes meet, I will go down 1 over 1. I get a dot right there. And I reverse that. Hyperbolas are always going to be, these hyperbolas will always be diagonal from each other. So I go up 1, left 1. And this time I get the reversed version of all the other ones. So every picture so far has been top right. It's been in these two parts of the picture. We're going to get these two parts when you have a negative. So graphing rational equations in their most basic form is just a matter of using your counting rules, the same things we've practiced all year long. In our last lesson of the chapter, we're going to learn more complicated rules for rational graphs that aren't just clean linear things like this, but that'll come later. For now, just make sure you feel real good about your counting rules, and you should be good to go on these pictures.